Hi, in this video, I'm going to explain why exception is a good mechanism for reporting errors. And we'll do that by going through some thought exercises. So the first one is, okay, let's imagine we're writing a function that performs a particular task. And this task would take 5 steps. So each of these steps is represented by a function called step, and step 1, step 2, all the way through step 5. Okay, and it does it one after another. Now, for this approach, for the first approach, we'll use return to report errors, i.e., that if any step 1 or 2 or 3 or 4 or 5, if it returns -1, that means that particular step has failed, and the rest of the steps must be aborted. So if we were to write a task function like this, what would it look like? Well, it'll probably end up looking something like this. Right, so we define a function task, assume all the step 1 through 5, those functions have been defined. So we'll first call step 1, and if it returns -1, we'll do something to handle it. In this case, we'll just say it failed, and then we do a return, right? Same thing for step 2. If it returns -1, we have to check what it returns and say something failed, and then return. We'll do this exact same thing every step of the way. We have to check the return value, and if it's -1, we handle it properly. Okay, what if instead of using return -1 to indicate error, each step function would actually raise an exception to report the error if it fails? And we would want to do the same thing, that if any one of them raises an exception, we'll abort the rest of the steps. So what then would the task function look like in this case? Well, it will look a lot simpler, right? Because we can just do step 1, 2, 3, 4, 5 without having to check the what it returns, because it doesn't return a -1 to report an error anymore, right? So, and when any of the steps raises an exception, let's say if step 2 raised an exception, then it would actually jump to the except block and skip the rest of the steps 3, 4, and 5. So that's great. It really makes the code a lot more readable, right? It's very clear. If we go through step 1 through 5, we don't have to repeat the code that checks the return value and handle it properly when the return values indicate an error. So, and then another good thing is that we actually when we repeat a lot of the same code, sometimes we could forget or do something slightly wrong, right? More code, the more possibility that we do something wrong, right? So less code in this case is really better. So less is more. Okay, so let's do another thought exercise. It's somewhat similar, but not quite exactly the same thing. Okay, so let's imagine writing another task function, and again, it takes 5 steps. Now, instead of task calling each of the 5 steps, in this particular task, each of the step would call the next step. So step 1 would call next step 2, and step 2 calls step 3, and so on and so forth. And now again, in the first approach, we'll use return to report error. So if the last step run into an error, then it returns -1, and the task must report something bad, and it must abort. So in this case, what would the task look like? So it would probably look something like this. And I don't even have enough room to write out all 5 steps. So I'm going to stop at step 3. So step 3 can potentially return a -1, and it should cause the entire task to abort. So then step 3 is called by step 2. Then what does step 2 have to do? Well, step 2, it has to check the return value of step 3. And if it's -1, then step 2 has to report it up to the step that calls step 2, which is step 1. And now step 1 also has to check the return value of step 2. And if it's -1, then it has to report to task, which calls step 1. And it's only by doing this then we can properly propagate the error encountered at step 3 all the way up to the top level task. And these do something. This is, if there's no error, then it can continue to do the normal thing that, each of these steps would have to do. But we're only concerned with the error reporting here, and that's why I'm not writing anything out for the do something here. In any case, I hope that you see it's a lot of work if we want to propagate errors up the call stack using returns. Now, what if instead of using return to propagate error up, we use exception. We use the mechanism of raising exception to report an error when an error occurs. What then would the task and each of its step functions look like? Now, remember, when an exception is raised, it is automatically propagated up the call stack until it is handled. Right? So here, step 3, if it raises an exception, that exception is going to be raised up to the caller of step 2. The caller of step 3, which is step 2. Now, step 2, it should propagate the error up to its caller, but it doesn't have to explicitly do that because that's automatically done. So here, when an exception is raised in step 3, it's propagated, and step 2 doesn't handle it, then it's propagated up to the caller of step 2, which is step 1. And again, step 1 doesn't have to explicitly handle it. It's automatically propagated up to the caller of step 1, which is task. And then at the top level task, then can handle the exception and see that, oh well, somewhere down, deep down in the call chain, an exception or an error actually occurs. And now, if there is no exception that is raised, then step 2, after it finishes whatever step 3 has to do, step 2 can just continue and do the normal thing. Same thing for step 1, continue to do the normal thing. So again, I hope that you see that by using exception, we save a lot of redundant work that does the check of if something goes wrong, do something. If something goes wrong, do something. So using exception, it's a lot cleaner to report error. All right, and finally, we all know that when an exception is raised and if it's not handled, then our program crashes, right? Now, why is that a good thing? Well, for that, it's not just my opinion. I'll refer you to PAP 20, which is the Zen of Python. And it says quite a few things of the design philosophy of Python, the language itself, and what Python programs should do. So two of the things that it says is that error should never pass silently unless it is explicitly silenced. So I hope you kind of get an idea what it means now. So what it's really saying is that um, the errors, if they're not handled, if they just silently occurs and we don't know that it's there, it's actually very, very bad. And that can happen if we use, like we just saw, return to report an error, but we somehow forget, either intentionally or unintentionally, to check the return value or the return errors. So in that case, something failed, but we don't know it. Now, when that happens, even though our program doesn't crash at that spot, but it could behave very badly somewhere down the road. And at that point, if the bug actually occurs a lot later, then it's actually very, very hard to trace where the original problem occurs. So it is actually far worse than if the program can just crash at the point when something fails. And as we saw, when something fails with an exception, we actually at least have a stack trace, so we know what the program is doing at the moment that it crashes. So that is actually a good thing for debugging. And the second thing that it says here, unless explicitly silenced, it just means that if we expect an error, an exception can occur, then we should explicitly handle it. So that's all I'm going to say about exception for now, and we will continue to use exception a lot throughout the quarter, and I'm sure you will use exception a lot as you do more and more programming.